Alright, what's up everybody, Mr. Mirror here, and today we have a video in Java on string methods. At this point we have talked about static methods. We have talked about instance methods. We have seen how to make our own methods briefly, our own method signature. We saw Boolean and a void one. It can be applied to other types as well. We have seen how to call methods. We have seen the different ways that we can use the results of the methods we call. Today's video, we're going to be dealing with those things with the string class. Let's start by opening up our file here, and I think we went with small time crooks as our class name. We did, and we have our main method in here, our public static void main string array of args. Let's just tag our end of main, and let's tag our end of class, and then let's get into the main method here and type. Now remember, a string data type, so I can say string phrase, and I can say in, I don't know what to write. So I can say that is my phrase, and this phrase I can do various things with. So I have a variable here, and this is a string object that I can use to call different string methods. We saw something similar when we dealt with scanner. I could call a scanner method next line, next int, next double. With the string here, I have various methods that I can call, and we're not going to look at every single one. There's a lot. We're going to look at a handful that are useful. One of the first ones I want to talk about is the length. So the length of a string, when I'm calculating out the length of a string, what the length method does. So first it returns an int. So we'll do int len, and then we'll do phrase.length. So this is my method call right here. So I use the object. This is an instance method that I'm calling. So I use the object name, and then I use the dots, and I say the method name, and then parameters or arguments. I would pass in arguments here. Arguments if the length method required them. It doesn't. What this method returns is it returns the length of the string. Now, how do we classify the length? We classify the length by counting every single character. I don't care if that character is a letter, uppercase or lowercase, a white space, an apostrophe, a punctuation, a symbol, something like that. We count every single character between the quotation marks. Every single character gets counted, and that gives us the length. And when we start counting from the number 1. So this I would be 1, then the space would be 2, D would be 3, and then we count everything in there. So if I wanted to print out the length, I could say system.out.println. I could print out my len. And if we run this code and we're going to move our window over to the right side to see everything, we see our length of 26. So that's how many characters are inside this string. Now, if I wanted to do, let's say like, hey Arnold movie. Right, we'll do like exclamation point there. So I could get the length of this, and this would be a different length. Now, another thing I can do, so that's the length method. Let's look at another method. Another method I have, we're going to keep writing over this section here. So that was the length method. Another method is I have a method called car at. And car at uses a specific data type, a car data type, a character data type. I'm going to say single letter, because a character, a car, can only hold a single letter. So it can only hold a single letter. If I try to give it more than one letter, I get an error. It's not able to do that. So it can only hold a single letter. So I have a car at method, and I can say, give me the character, right? Give me the car at, and now I have to give in here, I need to pass in something. I need to pass in an index location. So every string is made up of indexes, right? So I have index 0. So indexing, when I start counting indices, right? When I have my multiple indices, I start counting at 0. So I have 0, 1, 2, etc. So the first character is always index 0. So if I say, give me the character at index 0, and then I would go system.out.println, and I would print out single letter, I would see my H come up, right? And if I said, give me the character at index 13, should be valid still, right? I get my O, right? It's going to be this O here. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? So if I said 16, I should get my E. Right? So that's car at. Okay, so that's a single letter. Now, there's another way to get a single letter, and I actually like this way better. So single letter. Another way to get a single letter is to use a method called substring. We're going to do system.out.substring. And when using substring, we have a couple different options. So let's actually do, instead of single letter, let's do last word. I want to just grab movie. So I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can put the number 12 in here, and I do my system.out.println, and then I would print out last word, and that's going to just give me the word of movie. So the way that substring works, when I give substring an index and only a single index, that is my starting location. When it starts at that location, it will go and capture from that location through the rest of the string. So if I said start at index 7, it would go to index 7 and it would capture from there through the rest of the string. So it starts there and it goes through the rest of the string. So that's one way that I can use substring. Substring also has the ability, let's say we just want the word hey. So let's say first word. With substring, I can also pass in 2 arguments. And when I pass in 2 arguments, what I'm actually passing in is I'm passing in the starting location, 0. So I want to start at the H. And then I also pass in the ending location. 4 will work. And how this works is it goes and it starts here at index 0. And then it goes to index 4. However, index 4 is not actually captured as part of the substring. Where the substring ends when I have 2 arguments is it ends at whatever number I put here -1. So if we go H, 0, 1, 2, 3, I'm going to end at the space after the word hey. And if I were to run this and I highlight my hey, you can see I get a space there. There's an extra space in that print. So if I were to change this to 3, I would go 0, 1, 2, I would end at the Y. So if I were to run it this time and highlight, it doesn't allow me to grab that extra space. That extra space is not printed. And I could go even further. Let's say that I want 6. So we go 0, 1, 2, 3, 4, 5. So we're going to end at the R. Index 6 is the letter N, but because I'm -1 on here, I stop capturing letters at index 5. So we're going to say hey and then AR, hey space AR. So I like this version of substring. It allows us to capture different parts. We could even capture a single letter, just like we did with car at. I could capture the H. To capture a single letter, the 2 indexes that I need to give are the start and then just go 1 out. I just go 1 further. So I say, give me the letter at index 0, go to index 1. But because this is actually 1 minus 1, is the last letter that I capture, it's really just saying, go grab me the letter at index 0. So by doing this, I would just give my letter H. And this version of substring, this version here, this becomes very useful if I have a loop and I want to capture certain letters. So let's actually do this in the context of a loop. We should have enough time here. So I'm going to say for int I equals 0. So I want to start at index 0. Then I'm going to say I less than phrase.length. Remember, length is our entire string. So length means go through each one of these things. So I starts at index 0 and then move to index 1, then move to index 2. So I'm going through letter by letter essentially when I do my for loop like this. And then I can say I plus plus. And then inside here, we'll do like this. And let's actually we'll do the print in here as well. And we'll call this single letter. And we'll say single letter. And instead of saying 0 and 1, so if I say 0 and 1, it's just going to print out a bunch of H's, right? I just printed out H's for basically every single letter in here. That's not capturing each letter one at a time. What I want to say is okay, I want to start at index 0. Well, I is representing index 0. Okay, so I want to start there. But then I need to get to 1. So I want to say, okay, start at I and then go to whatever I plus 1 is. So if I'm starting at index 0, and then I say I plus 1, I'm saying 0 plus 1, which is 0 and 1. And then I move on to the next letter and then I is equal to 1. So I'm on the E and I say, okay, start at index 1 and then go to index 2. So that's my E. And then I move on to the Y and I say, okay, start at index 2 and go to index 3. And by doing this, I can get each letter of Hey Arnold movie printed out on its own singular line. I can get each character printed out on its own singular line. So this is kind of powerful. This is actually pretty powerful. If I wanted to check a string to see if certain letters appeared after each other, if I wanted to see if a chain of letters appeared after each other, now I could say, I don't have to stop here. I don't have to stop at I plus 1. I could say, okay, give me I plus 2. But if I do this, right, if I do this I plus 2, there's the very likelihood that I'm going to run into an error, right? And if we actually expand this out so we can see it better, I went out of bounds because it tried to begin at 16 and end at 17. So I became 16 and it added 2, which was 17, and I went too far. So you have to be careful. You have to be careful if you're going to do more than just I plus 1 inside your loop. If you are, there's a very likelihood that you are also going to have to do some subtraction on your length. You might have to subtract 1 or subtract 2, depending on how far you want to get. So you have to be aware of that. If you're going to do further than I+1, then you're going to need to add something up here potentially. So just keep that in mind. Okay, what do we have next? Let's talk about how do we compare a string to see if it's equal to another string. So normally, right, if we have an if statement, we saw relational operators that would double equal sign. And I said, okay, 5 equals 5, and this was system.out.println, and this was same. And then we'll do an else statement just to kind of show this else, and then we'll say not same, system.out.println, and then we'll print out not same. All right, so let's go string phrase 2, and we'll say phrase 2 is equal to Hey Arnold movie. Okay, let's do string phrase 3, and we'll say phrase 3 is equal to phrase 1, or just regular phrase. I'm sorry, not phrase 1, just regular phrase. And then we'll say string phrase 4 is equal to a new string. Now, we haven't seen this before, but we'll say a new string, Hey Arnold movie, and we'll write it like that. Okay, so let's see how these compare. So if I were to run this, we would see 5 equals 5, and that's the same. And if I were to say 5 equals 6, I would see not same, right? They're not the same thing. Okay. Now, what if I were to do this with strings? So I say phrase 2. They're both Hey Arnold movie. I just copied and paste. So what do I get here? I get same. Okay. And if I were to say phrase 2 compared to phrase 3, are they the same? They are. Okay. And if I were to say phrase 3, is that the same as phrase 4? They're not the same. Okay, well, what about phrase 2? Is phrase 2 equal to phrase 4? I see Hey Arnold movie and I see Hey Arnold movie. Why are they not the same? That's because the double equal sign, when using it on strings, tests the reference location to see if the reference location is the same. Are these pointing to the same reference? So phrase is pointing to a different memory location. Remember how reference types work. At our reference location for phrase, at our memory location for phrase, what we actually find in there is like a treasure map. We find another reference location that actually points to this. Phrase 2 is at a different memory location, but it's pointing to the same reference location as phrase. That's why they were the same. Phrase 3 is pointing to the same. It has the same contents and it is pointing to the same reference location as phrase. However, phrase 4, because I said new string here, and we don't always have to do this, but it's important to kind of show off that they're not the same. Doing double equals can give you incorrect results. These are the same words. Hey Arnold, exclamation point movie. This is the same exact wording in both of these. So I should receive same. I am expecting to receive same. But the way that the string pool and heap memory works, again, we're not going to dive into that discussion here. But the way that this gets set up in the string pool and the heap memory, these are actually at different reference locations. These are actually pointing to different reference locations. So that's where this other method, dot equals, comes into play. Dot equals. And dot equals test, are the contents the same? Letter for letter, is phrase 2, letter for letter, character for character, the same thing as phrase 4? So dot equals, when testing strings, is a better option. Dot equals is a better option here. Character for character, are they filled with the same characters? That's normally what we want to be testing when we are testing equality of strings. So double equal sign becomes dangerous when we're dealing with strings and when we're dealing with reference types, because we could get the wrong results. If I'm expecting these are the same words, why did I get not same? So dot equals is a better method to test there. Okay. Keep that in mind. All right, let's talk about, we have phrases here. So let's talk about compare to. Let's talk about compare to. Okay, let's do system.out.println. What are we going to do after? Okay, this is fine. We'll do compare to. We'll do Hey Arnold movie. Phrase 2, we'll do Hey Arnold movie. Phrase 3, we will do like this. How do I want to do this? I don't like this. Okay, let's just do Arnold for each one of these. So compare to. Compare to is going to test our strings. It's going to compare our strings against each other. We'll get rid of phrase 4. It's going to compare our strings against each other. And let's see, what can we add here? Let's do like S and Z. And then we'll do Z. So the way that compare to works, compare to, I say phrase dot compare to phrase 2. So I have my outside and I have my inside. I have my outside and my inside. So compare to, if the outside comes before the inside, lexicographically, dictionary order. We say lexicographical order, but dictionary order. So if my outside comes before my inside, then I get a negative number. So that the way that this works is it will go letter by letter until there's a difference, Once it finds a difference, I will get the result of that. So my outside phrase came before my inside because S comes before Z. So I got a negative number. If the outside comes after the inside, I will get a positive number because this time the outside Z comes after the inside of just regular phrase. So I get my positive number. If they are the same, I get a 0. And then the last thing I want to show off here is we'll do outside comes before. So outside is going to come before inside. So I expect a negative number here. The reason that I expect a negative number there was because our last rule, uppercase letters always come before lowercase letters. So even if this was like an uppercase Z, it would comes before lowercase letters. So uppercase always comes before lowercase. The last thing that I want to show off, let's go back to, hey, Arnold movie. And the last one that I want to show off is index of. So index of, and again, this one's kind of powerful inside the context of a loop, but the video's gone on long enough, so we're not going to do a loop to kind of show this off. But we'll say phrase index of, let's go with a, what do I have? Do I have multiple in here? Let's do an O. So I want the index of my O. And what this is going to be is it's going to show me the first index location of the first O that it finds. So 0, 1, 2, 3, 4, 5, 6, 7. I expect 7 to show up here. So the index of the O is at index 7. Now, if I could say, give me the index of an O starting from index 8, I won't see 7 because the first O is over here. So I see, okay, from index 8, my first O is at index 13. If I looked for a Z, I would get back a -1. So index of is pretty powerful. It tells you if a letter exists in the string because you'll get back a number. If you get back a -1, it doesn't exist. You can also find out if letters exist after a certain point. So that's index of. So that one was kind of quick to go over, and it is important. It is an important one. It is useful, but there's not a lot to it outside of that. So I pass in, so index of, I pass in whatever letter I'm looking for. Now I could pass in a substring. I could say, okay, give me the index of my phrase dot substring of letter 0, 1. So again, this is, I'm hard coding these numbers, but in the context of a loop, I might not know what index I'm on, but I want to find out the next value of that. So tell me, does this letter exist after this location? So I want to say after index 2, right? Does this letter exist after index 2? So again, in the context of a loop, these would all be variables that you could be checking. You could check, okay, does the letter I'm currently looking at exist somewhere else in this word, in this string? Does it exist at the end? Does it exist in the middle? What index location is that? Once you know that index location, then you have the ability using substring to go directly to that index location to capture that letter itself. And you have a lot more options there. So in the next video, we're going to talk about, so that was string, and strings are using instance methods. So we just saw how to do some instance method stuff again. We make our object and then we use that object to call a bunch of methods here. In the next video, we're going to switch over to static methods. We're going to be in the math class. So we're going to do some static math with those methods in the next video. Until then though, everybody have a week.